Okay, today we're going to learn how to take equivalency statements and turn them into conversion factors. So you probably want to take a little bit of notes on this and have your metric number line in front of you. So there's going to be a couple conversions that we're going to definitely need to know, and I'm going to explain them to you. The first one is going to be grams to kilograms. So an equivalency statement has an equal sign in it. And the first step to these equivalency statements is we have to figure out which unit is bigger. If you remember, I talked yesterday about the fact that small units get the bigger number, big units get the smaller number. So when you look at this, you say, oh, grams and kilograms. Kilograms is the bigger unit, so it's going to get the small number of 1 because I don't like dealing with fractions or decimals. And then you're going to find on the number line the prefixes that we're dealing with. Kg is kilograms, so you find K on the number line. G is a base unit and doesn't have a prefix, so you're going to go from K to G. If you look on the number line, go K to G, you'll see that there's 3 arrows between base and K. So that's also the same number of zeros. So my equivalency statement is there's 1,000 grams in 1 kilogram. So now I can use these equivalency statements to develop some conversion factors. Conversion factors allow us to convert from one unit to another. We're in the metric system, so these are nice and easy numbers. Not like the English system that are confusing, like 5,280 feet in 1 mile is a much more difficult problem. So each equivalency statement can be made into 2 conversion factors that will be reciprocals of each other. If you're looking to cancel out kilograms, you would use the one I'm writing right now. So if you're looking to cancel out grams, you would use the first one. I'm going to show you an example of some problems. So we're going to do word problems because a lot of times people think that word problems are a little bit harder, but if that's the case, we really just need some strategies for solving them. Once we get comfortable with them, we'll see they're just like any other problem. So how many kilograms are in 72.96 grams? So the first thing I'm always going to do is look for my given. My given is going to be the one that comes with the numbers. So remember, we're in chemistry class, no naked numbers. So my given is 72.96 grams. I'm going to take my given and draw it in brackets. I'm putting a 1 on the bottom just as a placeholder because this number doesn't happen to have any units on the bottom. Some will, some won't. So if there's no units on the bottom, I'm just going to put a placeholder 1 there. Now I have to go up to my conversion factors and decide which one I'm going to use. In this case, I need the units of grams to cancel out. How we cancel grams out is have 1 on the top and 1 on the bottom. So the unit that is in the given will always be put on the bottom in the next conversion factor. I'm going to fill in the numbers. 1 goes with kilograms and 1,000 goes with grams. Now you can see grams cancels on the top with grams on the bottom. So just like in math class, so we're using all the same strategies. So now you multiply across the top 72.96 times 1. We all know we can skip that times 1 step. So basically it's 72.96 divided by 1,000. And your calculator is going to give you, fortunately, these kind of problems, because the conversion factors are so simple. They're not going to mess with you too much when it comes to significant figures. So the answer is going to be 0.07296 kilograms. You have to make sure that your given and your answer have the same number of significant figures. This right here is a definition. So it has unlimited significant figures. Same with this and this. So when you're going to solve problems, the number of significant figures in your answer will be the same as the number of significant figures in your problem. Let's do another one. How many grams are in 0.542 kilograms? So again, I'll find my given. My given comes with the numbers 0.542 kilograms. And there's no units on the bottom, so I will put it over 1. So I'm going to go up to my conversion factors again, and I have kilograms in my given, so I know I need kilograms down here to cancel. And I'm changing it to grams. So I'm going to find the conversion factor that fits this pattern. And it's going to be 1,000 on the top and 1 on the bottom. So this time you're going to multiply 0.542 times 1,000 divided by 1, and it gives me an answer of 542 grams. My given has 3 significant figures because this is a leading zero that's never significant, and my answer has 3 significant figures, so we're all good. So this particular pattern, you're going to need to remember kilo is super common. So going back and forth from grams to kilograms is going to be a factor of 1,000. Let's go to the second one that is super common. Let's do centi and meters. So the first step I'm going to ask myself is, which unit is bigger? In this case, meters is a larger unit, so it's going to get the 1. Centi is a smaller unit, so it's going to get 1 with some zeros. How many zeros? You see how many arrows are between centi and base, and that's 2 arrows, so I'll get 2 zeros. I'm referring to the metric number line. My conversion factors that I can use to solve problems are as follows. So with the equal sign, this is called an equivalency statement. These are called conversion factors that are made from equivalency statements. Each equivalency statement can give you 2 conversion factors. So now let's see how some practice problems would look. How many meters long is a book that is 791.5 centimeters? So I'm going to put my given 791.5 with units, no naked numbers. There's no units on the bottom, so I'm going to put a 1 as a placeholder. I'm going to look up at my conversion factors and recognize that whatever units my given has to go in the bottom in the next step to cancel it. So I have 1 meter on the top and 100 centimeters on the bottom. So in my calculator, I'm going to take 791.5 and divide it by 100. And my calculator gives me an answer of 7.915 meters. 4 significant figures in my given, 4 significant figures in my answer. That's a pretty big book, but we're going to go with it. Okay, We'll do one the other way. How many centimeters is 22 meters? So I'll take my given. It's the one with the numbers. So 22 meters over 1. I'm going to look for the conversion factor that has meters in the bottom so I can cancel it. 1 always stays with the large unit of meters, and 100 always stays with the unit of centimeters. So this time in my calculator, I'm multiplying. So 22 times 100 is going to give me 2,200 centimeters. Make sure you don't add a decimal point in there because we need to have two significant figures from our given in our answer. Our last conversion factor that we're going to see all the time is milli. So this time we're going to go from base to milli. Milliliters is a super common unit in chemistry class when you're measuring volume. We don't often use huge quantities in this classroom to need to use liters. So we look and we say, oh, milli is small. It's a small unit. So liters is the large unit, gets the 1. And milli gets a 1 also with some zeros. Count how many arrows are between base and lowercase m for milli. And you'll see it's 3. So 3 arrows gives me 3 zeros. There's 1,000 milliliters in each liter. Let me do some conversion factors up here for you to choose from. How many liters is a 750 milliliter soda bottle? So 750 milliliters is my given. Put it over 1. I'll pick the conversion factor from up here that has milliliters in the bottom so that I can cancel it. And the number 1,000 always goes with milliliters. And the number 1 will go with liters. So this time I am dividing 750 by 1,000. Now let's check this out. 750 only has 2 significant figures. So if I do this, that's going to be wrong because this is a non-significant leading 0, but this is a trailing 0 and there's a decimal here. So that's 3 significant figures. So the correct answer would be to report it like this: 0.75 liters. You've probably seen a 750 milliliter bottle before. How many milliliters is 16.2 liters? So we'll take 16.2 liters, put it over 1. Find the conversion factor up here that's got liters on the bottom to cancel. And liters gets a 1. This time we're multiplying. So if you're going from a big to a small unit, you're going to multiply. If you're going from a small to a big unit, you're going to divide. General rule of thumb. So this time we're multiplying, and I get an answer of 16,200. For today, we're also going to do some more unusual conversion factors. But if you can do those 3 conversion factors in this class, you will be fine. Centi, milli, and kilo between base is where we're going to be spending most of our time.